we go, guys.
Okay, so Reagan and I are comparing basics.
Depends on what your family eats. Okay, guys, let's play it forward here. We go on to have enough time back in lab. So really quickly, if you weren't here last time, the notes are up there. The 2020 notes are up there. I also put the other notes from other years up. You needed to do part A at home. So before you turn in your lab, you need to do part A at home. That's just testing 20 things. Okay?
Can I do it today?
You can do it whenever. Okay? By the time we're done with the whole lab, you're going to upload the whole lab. Okay? So you're doing each part at different days. Today in lab, we're going to do part B. I've got everything in lab ready for you, and it should be real close to where your lab station is back there. And we'll talk about that more later. We're going to have some instruction right up the front. We are doing part B, which is neutralization, indicators, and behaviors of salts and buffers. Next time, we're going to do our first titration. We'll have a little bit of lecture at the first, and we're going to go back. We're going to do 2 simple titrations and then 1 with a pH meter. Because I want to make sure that you know how to do a simple titration, because we do those quick first, so we know about when the change is going to occur and we can slow down. Okay? And you can sort of see what's happening the rest of the time. After the first titration, we're going to talk about salts and buffers, and then we're going to do our beverages, which is our last part, part D, and the parts of the buffer that go with that. And then we're going to do cleanup with your homework and finish writing up the lab, and then the review on the 18th and the test on the 19th or the 20th. Okay, so it's coming down fast. Now, last units, so in the last term, we're going to have 4 chapters that we're going over. The last 3 tie really closely together, so I'm not going to spend a lot of time on those last 3 because I want to have a little bit of time for us to do a review for the year. Because that last test, that 13th test, is 20% of your grade, so I want to make sure you do really well on it. Okay. I'm also thinking that I'm going to probably have the day before the test, during lunch, I'll have a lunch review. Okay? And you can come in for a lunch review for those of you that would like extra help, and I'll probably have some kind of treat or something in there for you as an incentive to come. You guys need to make sure you do your Learn Smarts and do your homework, and I feel like I'm a broken record, but if you don't do them, it's like going and watching math, do the lectures, but never doing any of the math and thinking you're going to ace the test. It's not going to happen. So make sure you do your homework. Do your Learn Smarts. Come in and get help. Do the review. It is the test, basically. All I've done is change some numbers. So make sure you understand it. Don't just do it, but make sure you understand it. Okay? So please come get help. Please, I put on the board 2 weeks in a row where I'm going to be and what help you can get from me. That being said, let's go ahead and go into our lecture today. If I can get it started. No, not from the beginning. Crap. I wanted it from a certain slide and it didn't want to go there. Okay, last time we went into naming acids, 6 strong acids, 6 strong bases. Who can give me the 6 strong acids and 6 strong bases? Okay, strong bases on the left of the periodic table, starting with lithium. Lithium hydroxide, sodium hydroxide, potassium hydroxide. Slide over. Calcium hydroxide, strontium hydroxide, barium hydroxide. That's the left-hand side. Lefts are bases. On the right-hand side are the acids. It's a swooping down. Starting at nitrogen, HNO3. Sliding to sulfur, H2SO4. Sliding over to chlorine, HClO4. Then going down, HCl, HBr, and HI. So you have 3 oxyacids and 3 binary acids. Okay, I'm going to go ahead and play this again to annoy you, but also to help you remember the song, because this is going to help us. Maybe if I can get the volume.
Bronsted and Lowry had a theory, which they came up.
Let me try this again. I've got the volume off, and it won't let me get to it until I turn it off. I'll turn it down a little bit.
Bronsted and Lowry had a theory which they came up with independently. In chemistry, the difference between an acid and a base is a base accepts a proton which an acid donates. When litmus turns from red to blue, it indicates a change in solution from an acid to a base. In chemistry, the difference between an acid and a base is a base accepts a proton which an acid donates. The pH scale lets you see the level of acidity. Above pH 7 is where bases go. pH 7's neutral with acids below. In chemistry, the difference between an acid and a base is a base accepts a proton which an acid donates. The pH scale lets you see the level of acidity. The difference between an acid and a base is a base accepts a proton which an acid donates. The difference between an acid and a base is a base accepts a proton which an acid donates.
Protons are a hydrogen, but it has a positive charge.
Yeah, so that's why it's don't negate. That's what makes it H2O and then salt.
Right. Okay, so what we're going to be doing, again, we're going to be doing the parts B of your lab. C is next time, so make sure you look at it. Okay, we are going to be working with indicators today, and indicators change color in the different pHs or different acidities. So as we're looking at this, we want to be able to, and this is in your notes, we want to be able to identify the acid and the base. So we have to look at both sides of the equation. Over here we have HBr on the left. On the right it becomes Br minus. What happened to the H?
Why is it post-conjugate?
Because they've asked us to do that.
What?
Okay, so HBr has lost a hydrogen. Is that the acid or is that the base?
It's the base. Acid.
The acid.
Acid. Okay, because the base will accept the hydrogen, right? So this is the base. Now, if we go backwards, going from the products to the reactants, which one loses the hydrogen? Bromine doesn't have a hydrogen to lose. This one does. So this is a conjugate acid. And conjugate just means if I'm going backwards. And this one would be the conjugate.
So basically they're just switched.
Yeah, they just switch. From side to side, they just switch. I'm going to, for the rest of this, call this CA. So know that that's CA and this CB, just so it doesn't take as much time. Okay, so you guys tell me. SO3 2 minus. This is the base because it's going to accept. And again, I'm going to shorten these to base and acid. So that makes water being what?
The acid.
The acid. Okay, what about the other ways, going backwards? Which one of these is the acid? Which one gives up a hydrogen? The OH gives up a hydrogen?
No.
It accepts it. So this is my base. So this would be my conjugate acid. Good. Okay, I want you to quickly do C, D, and E, and let's see how well you can do on those. Just really quickly, see if you can figure out the acid base, conjugate base. On your own.
So the acid, so just double check. The acid donates to
Acid donates a hydrogen that the base accepts. The difference between an acid and a base is that base accepts a proton that an acid donates. That's why I wanted it stuck in your head.
H3O base.
H3O is an
Oh no, it'd be in
acid because it can donate a hydrogen, right?
conjugate acid, right?
If it's on the product side, yes. The difference between an acid and a base is a base accepts a proton that an acid donates. So a base from one side to the other gets a hydrogen. An acid loses one. Right. So here again on C, hydrogen sulfide gas, which is also called hydrosulfuric acid, goes from having H2 to having just one H. So it has donated, so it's an acid. Water has accepted it, so it's the base. Going backwards, H3O becomes H2. That means it's donated, it's a conjugate acid. That leaves HS as being the conjugate base. Okay, who can tell me what water is on D?
Acid.
Good. It acts as an acid. What about NH2? That would be your base. What's OH minus? Conjugate base. And what's NH3? Okay, good. How about the bottom one? Water.
That's an acid.
It has to be an acid because it's the only one that has hydrogen, right? So water here has to act like an acid. Doesn't want to write, but it has to act like an acid. PO4 has to act like a base. That means hydrogen phosphate acts as a conjugate acid, and OH minus acts as a. Okay, now let me point out some things really quickly. Do you think water is a strong acid? No. But its conjugate base is a strong base. OH minus is a strong base. So if I have a weak acid on one side, it's going to become a stronger base on the other side. If I have a strong acid on one side, it's going to become a weaker acid, like our top one, on the other side. Okay, or a weaker base, weaker base. Okay, so let's go forward here. We're going to write the conjugate acid and conjugate base to the following. So, we'll do the conjugate acid first. So conjugate acid to HF, if it was possible.
So the HF minus.
It would be H2F positive, right? Because it's adding one. Now, that's probably not a real true thing because fluorine does not like to share. Okay? But if I was to do the conjugate base
Where
over
do you get
here,
the extra H from?
so I'm doing the conjugate acid or conjugate base to these compounds.
Oh.
Okay, so if I'm doing the conjugate base, what happens? Take away hydrogen, so it becomes F minus. Okay, what about B? What is my conjugate acid to this? The minus goes away because I added a positive, right? What would the conjugate base be?
Would it just be
SE plus?
SE,
Oh, SE minus 2?
2 minus or minus 2, yes. Okay, what about this one, H, hydrogen phosphate? Conjugate acid,
2PO4 minus.
good. And the conjugate base? 3 minus, because I add one more negative. Okay, if it was possible on the bottom, H2Cl,
Plus.
and it would be a plus. I'm going to tell you right now, these are not possible because these are strong acids. They won't do it. Okay, so as far as being conjugate, doesn't like it very much, but conjugate base for this one would be what? Cl, just minus. Okay? When we talk about conjugate acids and conjugate bases, we're usually having two weak ones go together or a strong and a weak. Okay, yes?
Are we going to have to know whether it can or cannot be possible?
So strong acids, strong bases. You need to know those. If you know those, you know everything else is weak. So that's 6 of each. Either you put them on your card or you memorize them. Okay? All right, let's look at this. We should be able to fit in what's missing. Okay? So we have an NH3 plus something yields NH4 plus NH2 minus. What is missing?
Is it NH3?
It is NH3. So if I have two NH3s together, one's going to be acid, one's going to act like a base. Okay, we have oxalic acid plus water yields something plus hydrogen oxide ion.
Maybe H3O plus.
Good, H3O plus, because the water here is going to gain a hydrogen from the oxalic acid. Okay, we have arsenic acid plus something yields ammonium plus hydrogen arsenate ion.
NH3.
Yeah, you just take one away from what's over here on the left side, it would be NH3 without a charge. You see how this works? Because these two go together, right? There's just a hydrogen difference. These two would go together and there'd be a hydrogen difference. So this one lost a hydrogen. Because this one lost a hydrogen, this inner one would have to have gained one.
So
So if I go backwards, I take one away.
So why would it be? Oh, does it carry the H with it?
So going from here to here, I lost a hydrogen, right?
Yeah.
So because I lost a hydrogen here, I had to gain that hydrogen somewhere, and it had to be here that I gained it.
But there's two hydrogens, so why?
I only moved one.
Why do you want more?
You always only move one hydrogen. Only one hydrogen never moves at a time. Okay, what about the bottom one? See if you can predict it, and then we'll put it up.
Is it H minus?
Try and figure out what it is by yourself, and then we'll put it up. So remember, this is probably going to tie to this, so this is probably going to tie to that.
Would it be HS minus?
Good, the HS minus is what we should have.
Because on the beginning part of it, I think there's a H2O, but then you go into like
This one doesn't have any H's, right? At all. But this one, going from this side to this side, lost one. So that means this one has to gain one. Because one has to give it up, the other one has to gain it. Okay? All right, going forward. Yeah, I'll go back. But the learning check, let me do this for this. I want you to tell me the conjugate acid, conjugate base in these. Acid base, conjugate acid, conjugate base. So label those as fast as you can in your notes. That learning check. There's two equations. I want you to label it all. Acid base, conjugate base. We okay to go forward? Okay. Conjugate just means it's on the product side and you went back, you would be going backwards to the reactants. So now if you acid base, this was going backwards. Which one would act as the acid?
I am 10% certain I have the right answer.
Did I get the acid base part?
So it's like,
I get that.
okay,
I thought the
acid
acid
base
base
is how the
is
acid. Okay, so this has to be acid, this has to be conjugate will be on the top.
So what would you say? How do you know if it doesn't have a charge?
You're always giving
Okay, let's see how well you did. Check it. Check it. See if you got them right. This is important. This will be on the test. Did you get it right? If not, let's figure it out.
I don't know how to do conjugate.
So it's just my for conjugate, this is now going backwards. Which one is gain hydrogen? That's what base. So we just put a C in front since it's on the product side. I just mixed it up. Okay, yes.
So like this one. But basically it's mixed. So it's like up there is conjugated acids, right? So like so if I can have it in a you just switch liquids and
Okay, let's go forward. Guys, we gotta keep going. We gotta be back in the lab here in just a minute. Okay, so acid-base description. So far we've done, thank you. So far we have done Arrhenius. That was, an acid has an H, a base has an OH. We did Bronsted Lowry. The difference between an acid and a base is a base accepts a proton that an acid donates. So we've done that. The last one is Lewis. Lewis has to do with the electrons, and only the electrons. So as we're looking at the electrons, a Lewis acid is a substance that accepts electron pair, and a Lewis base is the one that donates it. If we remember boron, boron only has how many around the outer shell? Look where boron is.
2.
It has 3 in its outer shell. 2 in the S and 1 in the P. It can't open that last one by itself. But it can accept somebody else's 2 electrons. Okay, because it can only get to 6. It can't get to 8. So if somebody else wants to donate 2 to it, great. Okay, that's an acid. This is a base. If we look at nitrogen, nitrogen has how many in its outer shell? Looking at where it's at.
4.
So you have 2 lithium, beryllium, and then 3 in the P, so that gives you a total of 5. So here's 1 in a bond, here's 1 in a bond, here's 1 in a bond. There's 2 unshared pairs of electrons right here. Those can be donated to, like boron trifluoride, in order to act like a base. Okay, so it's sort of backwards. Now the base is donating electrons, and the acid's receiving. Okay, on the others, the acid is giving a hydrogen, a positive proton, and the base is receiving. Okay, so this is backwards. Okay, so here we look at this. The acid would be the H plus, the base would be the water because it has an H or 2 electrons to donate, and we get H3O plus. What's happening here? This is the way you can really quickly tell if you've got a Lewis acid-base reaction. What is different between this one and the Arrhenius or the Bronsted Lowry?
The charges change.
Okay, so on an Arrhenius, you have an acid base, you get salt and water, right?
This one just makes one.
Bronsted Lowry, you have an acid, a base, a conjugate acid, conjugate base.
This one just has one product.
Acid base product. It always just makes one thing. Because in order to donate electrons, they have to come together and make one thing. Yes?
Okay, but the other one it gives us this one it gives us salt and water, but then what does this one give us? Just,
So this one just gives us one product.
so it will never just be a salt or a water, it'll be
One product. So Arrhenius, you get salt and water. So if you end up with water, you know it's Arrhenius. If you end up with a positive and negative, that's Bronsted Lowry because a proton moved, a hydrogen moved. Okay? If you end up with just one thing, it's Lewis. Okay? All right. So Lewis can work several different ways. When we have Lewis acid, it can be a hydrogen. It doesn't have to be a hydrogen, like I told you with the boron trifluoride. But the base needs to have unshared pairs of electrons, at least one, that it can share with somebody. Remember I called these ghosts, and they sort of scare down the angle? Don't call them ghosts, but get in your head that same thing. Okay, so interactions here. This is what's happening in our body. We use Lewis acid-base reactions all the time in our body. With the Hem group, this is how we can transport oxygen and CO2 throughout our body because the Hem interacts with stuff in our body to form those bonds because of the iron that's there. The hemoglobin in the iron is the Lewis acid. And oxygen and CO react as Lewis bases. So when it comes across oxygen or CO2, it's attracted to that iron in the Hem group, and it's attached, making one group rather than two. So this is how our body is able to take CO out of our body and transport O2 to the rest of our body.
Wait, can you go back for just a second?
Huh? You okay? Okay. Going forward then, maybe, okay, summary. Want to really quickly just get all of them up here so we can see really quick. Some examples. Remember I told you radius. You're going to get acid, base, salt, and water, right? Bronsted, acid, base, conjugate acid, conjugate base. I have charges on the product side. Really quick, I know that's Bronsted Lowry. Lewis, 2 things heading to 1. If I end up with 1, I know it's Lewis. So those are just really quick ways to tell what kind of acid or base I've got. Okay? The only one that can have conjugate acid, conjugate base is Bronsted Lowry because it is a 2-way reaction. It can go both ways. Arrhenius, it's 1 way. I can't take salt and water, put them together, and get an acid and a base. It doesn't work. It's a 1-way reaction. It's sort of like burning wood. I'm not going to take burnt wood, coal, and make it back into wood. Okay, it's a 1-way reaction. Lewis bases are also 2-way reactions, but the thing here, again, I only have 1 thing in the product. This is where it works really well with our body in the heme group. When it gets to where it wants to get to, I have a release mechanism. I can get that oxygen off. I can get that CO2 off, our CO in my lungs, and I can get rid of it, or CO2 in my lungs and get rid of it. Okay? And I can transfer oxygen where I need to. Okay, so we're going to go back into lab, and we're going to be working on these parts of our lab, our Bs. You must have the B pre-lab done before you go back in lab, and you need to have it stamped off before you go back. A couple of things I need to tell you before you go back. Number 1, I have put areas throughout the lab that have all the chemicals that you need, so you don't all have to come up to the front. There's one in the front, and anytime you see a red basket, that lab station is for everybody to go and get chemicals at. Okay, so there's 4 chemical stations where you can go get stuff at. So you don't have to come all the way to the front or all the way to the back. I thought that would be easier. Okay, we are working with acid and base. The 1 molar is the one that you need to be careful with. Okay, that's more concentrated. But that first part where you're doing the neutralization with the 1 molar and 1 molar, you need to get that started first so that it can be evaporating. Once you pour it into your Petri dish, make sure you sort of spread it around so it's very thin so it can evaporate. If you want to evaporate it faster, put it in the hood because the hood has constant air moving through it. And it'll help you get that done faster. Just take and put a mark on yours so you know which one's yours. Okay? When you are finished, I need you to clean up everything at your station. And then I need you to make sure everything's in baskets so I can pick it up fast and get the other stuff out for you. Okay? Questions? Okay, the only thing I don't have out for you that you'll have to come get from me is a calculator to run your pH meter, the pH meter, and the easy link part. Okay? All right, let's go.
Where's the stamp?
Can I get so I did like whole hair pre-lab already.
Yeah, me
That's
too.
good.
So can I get that sketch off?
Okay, if you don't have the whole pre-lab done, then I'm just going to stamp by B.
Thank you.
So come see me first.